So this time we're finding the stationary point and determining its nature. So we know stationary points exist when the first derivative is equal to 0. So our function needs us to apply the product rule. So derivative of x is 1 times the natural log of x plus x times the derivative of natural log of x, which is 1 on x. Clean it up to give us natural log of x plus 1. So stationary points exist then when, as we said, when the first derivative is equal to 0. We set natural log x 0, we get the natural log of x is equal to minus 1. So if we apply our definition of our log here, we know natural log of x is equal to minus 1, so x would equal e to the power of minus 1, or x is equal to 1 on e. So that's how we're going to get x is equal to 1 on e there. We're just doing the definition of a logarithm. When x is equal to 1 on e, we substitute it back in. We get 1 on e times natural log of 1 on e, which we just thought was equal to minus 1. And so that gives us minus 1 on e. So that's our point. Let's test the first derivative when e to the power of minus 2, first derivative is less than 0. When it was e to the power of minus 1, we knew it was equal to 0. And when x is equal to 1, you're going to get the first derivative greater than 0. So you've got a curve that's falling, then it's stationary, and then it's rising. So it looks like that. So it must be a minimum. So there's our stationary point, 1 on e minus 1 on e, and it's going to be a minimum turning point because we've used our gradient. You could have used second derivative, that would work as well, but it doesn't. But as long as you can prove there's a minimum one way or the other, it's not. You can use whichever you like.